Calculate each of the following octal arithmetic. So we are given two questions here, Roman 1 and 2, and we are told they are octal arithmetic. So in short, we mean that the numbers are in base 8. So the numbers are in base 8, and before we can perform this, I would like we go back to the normal operation of numbers that we know, that is usually from base 10. So for example, let's consider the addition part. If you are given normal numbers and you have to add, for example, we have 56 plus 66, and you are told to add the normal addition, not binary, not octal now. What you do, you have 6 plus 6, you get 12. And when you get 12, you write 2 carry 1. You write 2 carry 1. But in this case, in short, in this 12, we have 10 times 1 plus 2. So in this case, it's like you are carrying a whole 10, because when we write 2, the remaining is 10. So it's like you are carrying a whole 10, but you don't carry the 10 to the next column, the value 10. You carry 1. That is because at this point here we have the 1's place value, and this is the 10's place value. So it's like you are carrying a 110, a 110. So because you are moving to the 10's value, you carry 1, which is the same as carrying a 110. When it goes to 20, you carry 2, which is meaning you are carrying 2 10s. So the same way we don't we do here when it comes to octal or any other system. When it goes, for example, in this case, we always carry if it is more than 10. If it is less than 10, we don't carry anything. So for the octal now, if it goes beyond, if it is either 8 or beyond 8, we carry. For example, in our case here, if we could have 5 and 5, we could have 10, and in that case write 0 carry 1. So in the same way, when you get 8, which is the maximum number in base 8, when you get 8, you write 0 carry 1. And when it is more than 8, you have to take the difference and carry the necessary carry. For example, if it is 9, 9 is 1 times 8 plus 1. So this becomes the sum, which you write here, and this becomes the carry. If it is 8, we write this as 1 times 8 plus 0. 0 becomes the sum, which we write here the same way we have seen for 5 plus 5. Then we carry the 1. But if it is less than 8, we write whatever we get. So let's look at what we are saying. This is 134, and this is 654. We are adding, and this is base 8. So 4 plus 4, we get 8. And we are dealing with the base 8. So this 8 can be written as 1 times 8 plus 0. 0 becomes the sum, and this becomes the carry. So I want you to be comparing with the way we do for normal numbers, the normal addition. When we get 10, we write 0 carry 1. So in this case, when you get, because these numbers are normally in base 10, so this case now we have base 8, 8 is now the minimum, the maximum that we can carry, or else the minimum. In that case, this is the minimum. So when you get 8, you have 0 carry 1, but you can always break it in this way. When you get more than 8, you have to take the difference. For example, if it were for example 5 plus 7, this is 12. So in 12 we can take the difference. 12 minus 8, we get 4. We write 4 here, we carry 1. So in this case now we have 0, we carry 1. We have 1 plus 3 plus 5, which is 9. So 9 minus 8 is 1. So 1 is the carry. Not so. 1 is the sum. We have 1 and we carry 1. Then 1 plus, that is 1 plus 1 plus 6 is 8. We get 8, we have 0 carry 1, and we drop the 1. So in this case we get 1 0 1 0, and this is base 8. Next we have the subtraction of octals. So let me show you the normal subtraction that we know. For example, if we have 5 2 minus 4 3, this is normal subtraction that we know. So 2 minus 3, it is impossible. So what we do, we carry a 1 here. We borrow, not carrying. We borrow 1 here. We remain with 4. But when we bring it here, it becomes 12. Why? Because we are borrowing a 10. Because at this point 5 is in the tens place value. So we are borrowing a whole 10. And not actually in the tens place value. What we are considering is the base. The normal operations that we do for addition, subtraction, multiplication is from base 10 numbers. So for any other base, if it were base 8, now at this point we could bring it here and become 8 plus 2 instead of 10 if it were base 8. So we get 10 minus 3 for base 8. But from base 10, which is the normal addition, we borrow 1 and it becomes 12. That is 10 plus 2. So in that case, now let's look at our subtraction, which is 2712 minus 1517. We have 2 minus 7, which is impossible. So we borrow from 1, we remain with the 0. When we bring it to where 2 is, it is the same as having 8 plus 2, which is 10. So 10 minus 7, we get 3. We add 0 here, we have remained with 0 here. So 0 minus 1, it is impossible. We borrow 1 from 7, we remain with 6. And when we bring it where 0 is, it's the same as having borrowing 8. 8 plus 0, we get 8. 8 minus 1 is 7. 6 minus 5, that one is possible. We have 1. And here we have 1. So in this case, we get 1173 base 8. So you have to be very keen on how you operate these arithmetics. And if it were base 16, we could consider a maximum of 16. If it is more than 16, you have to carry if it is addition. If it is subtraction, you have to borrow, and so forth. So you have to compare with the normal addition or subtraction that we know. But if you get the concept, then there is no need of that. I was just showing you how the applied rules of octal come in, comparing with the normal operations that we know.